What are cloudbursts and why might a warming world make them even more dangerous? Cloudbursts are sudden and extreme rainfall events that occur over a very short duration and in a localized area, usually resulting in devastating consequences. Defined as rainfall exceeding 100 millimeters in an hour within a confined geographical space, cloudbursts differ from regular heavy rains due to their intensity, unpredictability, and the catastrophic flash floods they trigger. These events often strike mountainous or hilly regions where steep terrain funnels the deluge into destructive torrents that sweep away homes, infrastructure, and lives. While cloudbursts have occurred throughout history, the frequency and scale of their devastation have come under sharper scrutiny in the context of a warming planet. The mechanics behind cloudbursts are still a subject of scientific study, but the core process involves rapid convection. Warm, moisture-laden air rises quickly, condenses, and forms highly saturated clouds. When the atmospheric pressure dynamics destabilize, these clouds release their water content almost instantaneously, dumping massive amounts of rain in minutes. In mountainous regions like the Himalayas, this process is amplified by topography that forces moist air upward, triggering sudden, concentrated rainfall. Because of the limited geographical coverage, traditional meteorological tools often struggle to predict cloudbursts with precision. The destructive power of cloudbursts lies in their immediacy. Unlike monsoon rains that accumulate over days, a cloudburst strikes without warning, leaving little or no time for evacuation or mitigation. Flash floods rush down valleys, carrying boulders, debris, and mudslides that can bury entire settlements. Roads, bridges, and power lines are destroyed within hours, isolating communities and hampering relief efforts. Agricultural land is ruined, livestock perishes, and water sources become contaminated, leading to long-term economic and health crises. The relationship between climate change and cloudbursts has become a growing concern among scientists. A fundamental principle of atmospheric science, the Clausius-Clapeyron relation, states that warmer air can hold more moisture, approximately 7% more water vapor per degree Celsius of warming. As global temperatures rise, the atmosphere's capacity to store moisture increases, meaning that when conditions align, significantly more water can be unleashed in the form of intense downpours. This mechanism is already linked to an observed global rise in extreme rainfall events, and cloudbursts are among the most dangerous manifestations of this trend. Mountainous regions, particularly the Himalayas, are especially vulnerable. The Himalayas are warming at nearly double the global average rate, causing glaciers to retreat and permafrost to melt. This weakens soil stability, making slopes prone to landslides when struck by sudden rainfall. Cloudbursts in such fragile environments result not only in floods but also in cascading disasters like landslides, glacial lake outbursts, and infrastructure collapse. The 2013 Uttarakhand disaster in India, often associated with cloudburst-like rainfall, killed thousands and underscored the peril of unchecked development in ecologically sensitive zones. Urban areas are increasingly facing cloudburst-related disasters as well. In cities such as Mumbai, Beijing, and Copenhagen, sudden cloudburst events have overwhelmed drainage systems, inundated streets, and caused billions in damages. In 2011, Copenhagen experienced a cloudburst that dumped over 150 millimeters of rain in less than 2 hours, flooding homes, subways, and businesses. In densely populated cities with poor drainage and rampant urbanization, impermeable surfaces exacerbate flooding, turning heavy rainfall into a humanitarian and economic crisis. The unpredictability of cloudbursts compounds the challenge. Because they often cover areas smaller than 20 square kilometers, cloudbursts are difficult to capture in weather models or detect through satellite imagery. Doppler radars and high-resolution forecasting tools are improving early warning capabilities, but reliable forecasts are still elusive. As a result, communities in cloudburst-prone zones remain vulnerable, relying on broader monsoon warnings that fail to account for sudden local disasters. Addressing the risks of cloudbursts requires both adaptation and mitigation strategies. On the adaptation front, experts emphasize better land use planning, strict regulations on construction in fragile zones, and reinforcement of critical infrastructure. Afforestation, slope stabilization, and riverbank strengthening can reduce secondary disasters such as landslides and erosion. Urban resilience measures include green infrastructure, sustainable drainage systems, and rainwater harvesting to manage sudden deluges. At the community level, awareness campaigns and disaster preparedness training can make a significant difference in survival rates when cloudbursts occur. Policy frameworks must integrate the growing risks of extreme rainfall into development planning. In many regions, hydropower projects, road construction, and tourism expansion proceed with little regard for ecological fragility, increasing exposure to disasters. Governments must incorporate climate risk assessments into infrastructure projects and enforce environmental safeguards. Regional cooperation is also vital, especially in transboundary river basins like the Himalayas, where cloudburst-triggered floods can affect multiple countries downstream. Cloudbursts, though localized, symbolize the larger story of how climate change is reshaping weather extremes. Once considered rare, these events are being reported with greater frequency across continents, from South Asia to Europe and North America. They highlight how rising global temperatures amplify existing vulnerabilities, especially in areas where human development has already destabilized natural ecosystems. The devastation caused by cloudbursts is not only a reminder of nature's power but also of humanity's responsibility to adapt and build resilience in a rapidly changing climate. The danger of cloudbursts in a warming world is not just theoretical, it is unfolding in real time. Every year, lives are lost, villages destroyed, and cities paralyzed by sudden, torrential rain. As the atmosphere continues to heat and hold more moisture, the intensity and frequency of such disasters are expected to rise. The question is not whether cloudbursts will become more dangerous, but how societies prepare for their inevitability. Inaction risks greater tragedy, while proactive planning and adaptation could save countless lives. Cloudbursts are a stark warning of the climate crisis. Localized yet global, unpredictable yet increasingly common, devastating yet preventable in their worst outcomes. In a world growing warmer, the need to understand, forecast, and prepare for them has never been more urgent.